Great. So welcome back to grade 8 math. We are now continuing on with chapter 9.6, which is the division of fractions. And as we looked in the last lesson, the division of fractions is quite difficult, but we can look at division in relationship with multiplication and realize or remember that division is the opposite of multiplication. So for example, if I have a certain number of pizzas and I have 10 pizzas and I want to see how many half pizzas are in 10 full pizzas, well, what I'm really doing in my head is I know that there are two half pizzas for every whole. So I'm going to multiply instead 10 times 2 rather than 10 divided by a half to find that the answer is 20 half pizzas in 10 full pizzas. So that's why fraction division is really tricky to calculate. So we can always just convert it into a multiplication if it seems too tricky to solve it as a division. So some steps to follow: convert all mixed fractions to an improper fraction. The reason why we do that is because as we looked in multiplication, we have to be able to have it in improper form for us to be able to multiply the numerators and denominators. Step 2, refine the reciprocal of the divisor and then change the division into a multiplication, because that's why we're changing our point of view as we looked at in the last lesson, and then follow through with a multiplication. So for example, we look at 1/7 divided by a third. This might be a tricky problem where I say I have 1/7 of a pizza left. How many thirds is there in that 1/7 of a pizza? 1/7 of a slice, 1/7 of a pizza. So if I have 1/7 of a pizza, I know that I don't have any full thirds in there. So I know that my answer is going to be less than 1. But it's a really tricky one to calculate actually how much is there of the 1/3. So what we'll do is we'll change this into a multiplication problem. So instead of 1/7 divided by a third, I know that there are 3/3 in a whole pizza. So in the whole amount, there'll be 3. So I'll take that 1/7 of that pizza, and instead of finding how many thirds are in it, well, I know that there are 3/3 in a whole. So in this case, I'll just multiply the 1/7 times 3, and that'll find out that I actually have 3/7 of a third gives me a 1/7, that slice that's left. It's really tricky to picture it that way, but it really does mean the same thing. So finding out how many thirds are in a 7th is the same thing as just multiplying that 7th times 3. So I know there are 3/7 thirds in 1/7. It's really tricky and awkward. If we look at question B, it might make a little bit more sense. I have 12 full pizzas, so I have 12 of those pizzas out there, and each of those pizzas is divided into 5 slices, and if each player on the team can eat 3 of those 5 slices, how many players can I feed in total? Well, I know I could feed at least 12 because each of them eats less than a full pizza. So I know that my answer will now be greater than 12 because not each player eats more than a full pizza. So I'll have some leftovers that I can feed more people with. So the question is, how many 3/5 are there in 12? Well, by answering this question, by looking at models, I can answer this question, but I can also answer this question by changing it into a multiplication problem. So step 1, convert all mixed fractions to improper fractions. Because I have a whole number here, it's not mixed, so I can leave it as is. But then step 2 is I change my division into a multiplication. So the division becomes a multiplication, and my 3/5 now becomes 5/3 because this is now the reciprocal of 3/5. Once I have that, I can multiply through. So 12 times 5 is 60. Oops. So 12 times 5 is 60. And my denominators now, well, I have the 3 there, but 12 is the same thing as 12 over 1. So 3 times 1 is 3. And then I can reduce how many 3's go in 60, and my answer is 20. I can also solve this problem by canceling factors as we looked at before in an earlier lesson. When I'm multiplying, I can see if there's any numbers that have common factors. Well, 3 and 12 have the same common factor of 3. So 3 divided by 3 is 1, and 12 divided by 3 is 4. So I'm left with that 4. Now I multiply through. 4 times 5 is 20, and 1 times 1 is 1. So it's 20 over 1, and that's just rewritten also as 20. So you could pause the video now as you work on letters C and D on your own, or we'll just solve this on the side. Again, it's tricky how to solve this 1 and 4/7 divided by 11. There's two ways of looking at it. I have 1 and 4/7 pizzas, and I'm dividing them into 11 by 11 people. How much of each pizza will each person get? I can look at that, or I can look at it as how many 11s are in 1 and 4/7, which is a really tricky example to follow. So what we'll do is step 1, convert our mixed fractions to improper fractions. So 1 and 4/7 is the same thing as 11 over 7, and I'm dividing by 11. And what I can do is I can convert this to a multiplication problem. So 11 over 7, change the division to a multiplication. And now 11, I find the reciprocal of that. So that means this has to flip upside down. That means the 11 has to be on the bottom. And now 11, well, what number was here? And all fractions, if there's nothing there, is a 1. So 11 over 1 becomes 1 over 11. And now I have nice factors that I can cancel when I have a multiplication. My 11s cancel out to make 1 and 1. So now my answer is 1/7. So that means if I have 1 and 4/7 pizzas, and I'm dividing that by 11 people, that means each person would get 1/7 of a slice, or 1/7 of a pizza. So let's just take a look at this last one. 2 and 6/15 divided by 6/10. I'll just show the procedure right now on how to do this one. Just convert all mixed fractions into improper fractions. So 2 and 6/15 is the same thing as 36/15. And then my divided by 6/10 becomes multiply 10 over 6. I have common factors again. So I have 6 and 36. So 6 becomes 1, and 6 goes into 36 6 times. And I can divide my 10 and 15 by the common factor, which is 5. So 10 divided by 5 is 2, and 15 divided by 5 is 3. I could cancel again some more. So I have a 6 and a 3 here, and this cancels out, and 6 divided by 3 is 2. So now I'm just left with my factors 2, 2, and the 1 and the 1 in the denominator. So 2 times 2 is 4, and 1 times 1 is 1. And so my answer just is 4. Let's see if we can understand why that's 4. It's basically asking, I have 2 and 6/15 of something, and I'm figuring out how many 6/10 go into that. And it kind of makes sense that it's about 4, because 4 times 6/10 is about 2.4. If I use decimals, it is 2.4 really. And that's a little bit like 2 and 6/15. If I can convert that one, 6/15 is really the same as if I divide each by 3. Divide this by 3 is 2/5, and 2/5 is the same thing as 4/10. So it really does work out as well if I look at it that way, or I can just convert it to multiplications and solve the problem as well. So it is really tricky, but make sure you just follow the steps and see if you wanted to draw some models to see if you can understand it. And if you have any questions, we can go over that in class again, and we'll just solve some more problems in class. Great, so hopefully you understood this lesson.